All right, well, what I have here is what used to be called back 25 years ago a bad boy charger with some parental controls. At the time when people were making chargers and naming them with fun names, this is a bridge rectifier here, and this is my AC input coming right from here. This AC input comes in, goes through this box here, and one leg of the wire is going through these outlets, which gives me the ability to put some kind of load, either a heat gun or a fan, in series with this bridge rectifier. And right now I got this guy charging a 12-volt battery right off of the 120 volts. And we see here I got my amp meter on here. Right now I'm charging at 0.7. Whatever load I put on this will determine how much charge power there is, and also the voltage. The higher the voltage that we're charging, the more of a load we're going to have. So watch what happens when I turn on this. You see our current goes up. And because I got a variable temperature setting on here, I can turn it all the way up to there. This will charge any battery up to about 140 volts. Or if you plug it into 240, it'll charge up to about 350 volts. But it has no control other than this load that you put on there. And I got this little fan running here at 7 amps. You put a light bulb on there or whatever, and as the voltage goes up on here, the amperage is going to back off on here. So it has very little controls, but it's very simple to make. You also want to have your bridge rectifier on some kind of heat sink, and probably shouldn't have more than 5 amps, maybe 8 amps, even though it's a 25, it might even be a 50 amp rectifier. You got to be able to have a heat sink and everything to handle it. But this is just for charging, emergency charging of batteries where either the battery is so dead it won't accept the charge. And this is good for car batteries too, because a car battery that's so dead that it won't accept a charge, when you plug this in here, it'll actually impress across the battery 120 volts, which sometimes gets the juices flowing in these, but it won't overcurrent it. That's the good thing. Your current limit is by whatever load you plug into this. And if I unplug my load, you see we get no current flow. And here's a little wiring diagram of it. See, I got my AC power coming in. It goes to the AC part of the bridge rectifier, out to the positive of the battery, back in through the negative, or vice versa, however you like it. Back from the AC out here now, this goes to the outlet. And the outlet is important because that's what, when you plug something in, determines how much current's going to flow through here. A handy charger, but it could also be considered dangerous. All bad boys are dangerous. Here was another bad boy charger that I found digging through my stuff, and we called this a bad boy charger with a capacity for violence, or capacity for danger. I've forgotten which one. And this has the capacitors hooked up in series with the input. And what that does is, this is in place of our load, but it also steps the voltage up. So this will actually step the voltage up, possibly double. And then we had the third world chargers. Third world chargers were, again, a little safer. I got one over here just to be going over all these chargers. And this was the third world charger. And this was a variable transformer with the same setup. Variable, it just has a variable transformer on the input. And there was lots of different ways. Oh, what a fun time we had back in the 90s making battery chargers. Everybody had different ideas. There was the light bulb charger, now that I remembered it, which used our light dimmer charger, which used a light dimmer. A light dimmer to control the current. And then people got a little more sophisticated and came up with voltage sensing and whatnot. There was a charger called the Roscoe, which was very popular, and he had actually made a light dimmer with some inductance to give the thing some manners. And you could put an inductor and a capacitor across, and it went on and on, and then at some point in all this excitement over chargers, because all these chargers, the one thing that they don't have is any type of power factor correction. They don't match, so they have a tendency to be a little hard on the AC line. And then this guy came along, Manzanita Micro, and he made a charger that was power factor corrected. And oh, look, another bad boy, a bad boy with a thing to keep it under control. But here's what the Manzanita charger looked like, and these were popular, although these were not isolated either. All these chargers would definitely shock you, shocking as that may seem. They were not isolated at all. Neither was his. And his answer for that problem was, if you want isolation, buy an isolation transformer. These guys here, when this came along, we could set any voltage from 12 to 400, and any input you put in, you could even put in DC. I had this one set up for DC. So these would take AC or DC. Had to get the polarity right. Oh no, actually you didn't. On the input you didn't, because it went through a bridge rectifier. But they had the unfortunate problem of, if you unhooked the load, or if you started them up, turned fully on, they might self-destruct. So that was a world of chargers. That I'm not exactly sure. Maybe somebody in the comments will put the date that Manzanita Micro came out with their charger. And at that point, before that point, almost all conversions were 120 volts. And then we went up to because that was the popular controller voltage, was a 120 Curtis. And then there was a 144, and people would step up the AC with a transformer. The evolution, I've made a few of those too, because 156 volts became popular with the Zilla controller, which actually he made 156 and 300 volts. So we had more challenge with and then we also, more challenge on making our chargers, but we also had AGM batteries, which were very particular about not being overcharged. And here's what we have today. Look at this thing. I think this is 6 or 7 kilowatts, a lot of power. The Manzanita charger that I just showed you, those guys were 2 kilowatts, and they were $2,000 back in the day. They weren't cheap, but they seemed like quite a feat at the time to be able to have any battery pack, just a knob that you could turn up and down. And they didn't overheat your extension cords. They had a good power, well, that was their thing, power factor correction. There we go. All right. Any thoughts on building battery chargers? This would be the place to discuss that.